Hi there, welcome back to the channel. Now let's discuss some methods of evaluating limits. Now there are about 6 methods of evaluating limits, and in this video I'm going to share with you 4 methods, excluding the L'Hopital's rule and Squeeze Theorem. Okay, in another video I'm going to be sharing with you the L'Hopital's rule and the Squeeze Theorem. Alright, so for in this video we are going to be discussing 4 basic methods, which are the method of direct substitution, then we'll now go to the factorization method, then method of reduction of power, then we'll go to method of rationalization. Now, if you are a student offering calculus in your first year, do well to subscribe to this channel, because I'm going to solve some calculus questions from some of your exam manuals. For those of you in FUTA, Nigerian universities, basically. So I'm going to pick questions from different search manuals. All right, so let's take the first one, which is I've prepared a list of questions from one textbook that I saw. So I just picked some of their questions and we are going to be resolving it. So let's begin with the simple direct substitution. So the first one says find the limit as x approaches 0 of x raised to the power 3. So when you have a question like this is very simple. Now, if you already know the direct substitution, that is the factorization, you don't know, you can skip the video to that part. But the reason I'm starting with this basic thing is so that we'll go from 0 to hero. Exactly. We'll go from, if you don't know anything about it at all, to you knowing much about it. Exactly. All right, so we have this. You simply substitute that, and then you have the limit as x approaches 0 of 0 raised to the power 3. And the answer is what? 0. So that's the limit of our function. Now the next one says that the limit as x approaches -1 of x squared minus 5x plus 6. All right, look at this one. We can also use direct substitution for this one. We're going to have limit as x approaches -1 of -1 squared minus 5 into bracket -1 plus 6. So we have limit as x approaches -1 of -1 squared is 1 minus times minus plus 5 plus 6. So 1 plus 5 plus this is equal to 12. So our limit as x approaches -1 is 12. Okay. Another question says that we should find the limit as x approaches 2. Find the limit as x approaches 2 of 3x minus 1 over x plus 5. Okay, so to solve this one, we can simply use direct substitution too, so that the limit as x approaches 2 of 3 over 3 into bracket 2 minus 1 and 2 plus 5. Now, if you don't understand what I mean by as limit as x approaches, all those terms I'm mentioning, I'll link the video of introduction to limits in the description, so do well to watch that video so that you understand what I am saying and what we're doing. So the limit as x approaches 2 of 3 by this is 6 minus 1 over 7, which is 5 over 7. So the limit as x approaches 2 of that function is 5 over 7. Our function approaches 5 over 7. The next one says the limit, so this will be number 3. Number 4, the limit as x approaches 0 of x cubed minus x squared over x. Now looking at this, we can substitute directly. Okay, now here we cannot substitute directly here. Okay, we cannot substitute directly here. So this is where factorization method comes in. So let's go to method 2 now. So you see that in the other method, the first method, we basically substituted directly. So now we have used this. Now let's go to factorization method. So the question says that the limit as x approaches 0 of x cubed minus x squared over x. Okay, so looking at this, because if we directly substitute, look here, if we directly substitute, we are going to have 0 cubed minus 0 squared over 0. So this is going to give us an indeterminate function. Okay, I'm going to give us some indeterminate functions. Maybe I should give us that now. I wrote them down somewhere. Indeterminate functions. So that you know which functions, when the function is indeterminate and when the function is determinate. Okay, so now the indeterminate form of functions, we have indeterminate forms. Then these ones are determinate. Determinate forms. Indeterminate form includes 0 over 0, plus or minus infinity over plus or minus infinity. Then we now have infinity minus infinity is indeterminate. We have 0 raised to power, or 0 into bracket infinity is indeterminate. 0 raised to power 0 is indeterminate. 1 raised to power infinity is indeterminate. And infinity raised to power 0 is indeterminate. Okay? Then, but infinity plus infinity is determinate. That will be infinity. Negative infinity minus infinity equal to minus infinity. Then 0 raised to power infinity is still 0, because 0 raised to power anything is 0. 0 raised to power negative infinity though. Okay, 0 raised to power negative infinity is actually infinity. Okay, so you should copy this down. Then infinity times infinity is equal to infinity. All right. So these are the determinate and indeterminate forms of our function. So looking at this, it's going to give us 0 over 0, which is what? Indeterminate. So when your function takes any of these forms, then it is indeterminate. You have to change the method you are using to evaluate the limit. Okay? So in order to solve this question, the first thing we'll do is to factorize first. So we're going to use factorization method. So by factorizing, we'll have the limit as x approaches 0 of x into brackets. Let's factorize x out. If we factorize x out, we'll have x squared minus x all over x. So this takes care of this. Well, at the end of the day, it's still 0. This minus, but 0 is determinate, exactly. 0 is not something that doesn't exist. 0 exists. Is that okay? An indeterminate form of function is a function that doesn't exist. Do you understand? It means that if a function gives you an indeterminate this thing, it means that it does not exist in that at that particular point, except if you have used the wrong method to evaluate it. So 0 squared minus 0 is equal to 0. Okay? So that's the answer to that question. Now the next question says that the limit as x approaches 0 again of 2x minus x squared. Okay, let me just write a few of these questions down. Then the next one says the limit as x approaches 0 of 3x, okay, this is 12 over 4x, 3x squared minus 5x over x. Then the limit as x approaches 2 of x minus 2 over x squared minus 4, and the limit as x approaches minus 2 of x plus 2 over x squared minus x minus 6. All right, let's solve this. So this we can factorize here. In fact, we don't even need to factorize yet. What we'll just do is, okay, there are two ways we can go about it. Is either we say the limit as x approaches 0 of 12x over 4x minus x squared over 4x. So if this be the case, this takes care of the answer. We have 3 here. So that we have limit as x approaches 0 of 3 minus, this becomes x over 4. So when you put 0 here, this becomes 0. And the limit as x approaches 0 is what? 3. Our function approaches 3. Because 3 minus 0, the moment you substitute 0 here, it becomes 0 over 4. Minus 0 over 4, that is 3. Okay? 3 minus 0 is 3. Then the next one says, the limit, so this is question 4, question 5, question 6, question 7, question 8. So the next one says, question 6x, the limit of 3x squared minus 5x over x as x approaches 0. You can factorize here too, or do what I did. I just divided by both, divide the numerator by, the same thing. Okay, but since we are talking about factorization, let's factorize. So we'll factorize x out here so that we have 3x minus 5 all over x, the limit as x approaches 0 of this. So x takes care of x. So by the time we substitute the limit as x approaches 0, we substitute 0 into the equation, 3 into bracket 0 minus 5. So what do we have? 0 minus 5. The answer is minus 5. Okay? Then number 7, the limit as x approaches 2 of x minus 2 over x squared minus 4. Now this is where your knowledge of factorization is very, very necessary. Okay, it's very important. So you know this is difference of two squares, right? So we have limit as x approaches 2. Difference of two squares, the rule says that if I have a squared minus b squared, that is the same as a plus b and times a minus b. Is that clear? So I'm going to make this into this case so that I have x minus 2 over. In my next question that come up like this, I will not be as expressive as this. So that's why I want you to see this. So this now becomes the limit as x approaches 2 of x minus 2 over x squared minus 2 squared, as looks like this, right? So it becomes x plus 2 and x minus 2. So x minus 2 and x plus 2. You can put it either way you want. So this can take care of this. Does that make sense? So our function now becomes we are going to reduction of power after factorization. Okay. So we have the limit as x approaches 2 of 1 over x plus 2. So now substitute this here so that the limit of our function becomes 1 over 2 plus 2, which is 1 over 4. Okay? Then number 8 says the limit, to find the limit as x approaches 2, negative 2 of x plus 2 over x squared minus x minus 6. Okay, so in this case, what you want to do is factorize this denominator, right? So how do you factorize the denominator? By quadratic equation. Okay, this is a quadratic equation, so this thing becomes, this guy, by the time you factorize, is going to give you x minus 3 and x plus 2. Okay, if you don't understand what I did here, you can just comment down in the comment section or just text me on my WhatsApp number. I'll send you my video on quadratic equation, okay? I'll send you my video on it. But I don't expect you not to know this, so this is quite simple. So we have the limit as x approaches minus 2 of x plus 2 over x minus 3. By the time you multiply this together, it should give you this. Is that clear? So this again takes care of this so that we have the limit as x approaches minus 2 of 1 over x minus 3. That will be equal to 1 over minus 2 minus 3, that is minus 1 over 5. And that will be our answer. And number 9, let's solve number 9. Okay. Number 9 question says, okay, let's write another list of questions. Number 9 says that the limit as x approaches minus 7 of x raised to power 2 plus 4x minus 21 over x plus 7. Number 10 says the limit as x approaches 8 of x squared minus 3x plus minus 40. Number 11 says the limit as x approaches 1 of x cubed minus 1 over x minus 1. Number 12 says the limit as x approaches minus 2, this one is long, well, let's still use it. As x approaches minus 2 of x cubed plus 3x squared minus 4x minus 12 over x squared plus 5x plus 6. And number 13 says the limit as x approaches minus 4 of x plus 4 over x cubed plus 64. All right. So let's solve from number 9. So number 9 says the limit of this guy. Okay, so in like manner, we're going to factorize the numerator. So how do you factorize this? That's going to give you, in fact, since you already know the trick, x plus 7 is going to be a factor. Okay, so if x plus 7 is going to be a factor, what will you multiply by 7 to give you 21? That's going to be 3, right? So that will be x minus 3. Okay, so if that's the case, then we have the limit as x approaches minus 7 of x plus 7 times x minus 3 over x plus 7. So this takes care of this. And then we have limit as x approaches minus 7 of x minus 3 only, right? So we substitute minus 7 to that is minus 7 minus 3, which is minus 10. So that's going to be our answer. Then let's go to number 10. Number 10 says the limit as x approaches 8. The limit as x approaches 8 of, I think I copied the wrong question. Limit as x approaches 8. Okay, it's supposed to be over something, over x squared minus 8x. X squared plus 3x minus 40 over x squared minus 8x. Because we are under factorization, so I expected that there's going to be, that there should be a denominator there. Excuse me. So we have that. We'll factorize now, yeah? So minus 40, so 3 and 40, so what is that going to be? That is going to be 8 and 5, right? Okay, so we have limit. What I'm just testing, what number do I multiply together to give you 40? That I will add, that will give me, add or subtract, add actually, that will give me this. So if I add minus 8 plus 5 to give me this, if I multiply minus 8 times 5 to give me this. So by using minus 8 and 5, okay? So equal to x squared minus x minus 8 and x plus 5. Yes. Okay, so then for this denominator, I factorize x out and I have x minus 8. So this takes care of this again. Then the limit as x approaches 8 of x plus 5 over x becomes, here, we substitute as 8 plus 5 over 8. That becomes, this was the 13 over 8. Okay, let's solve number 11. Number 11 says the limit as x approaches 1 of x cubed minus 1 over x minus 1. So what do you do here? The first thing you want to do is, now seeing this, you should remember this polynomial identity, that I can turn this into limit as x approaches 1 of x cubed minus 1 cubed over x minus 1. So remember this identity, that a cubed minus b cubed is equal to a minus b, then into bracket a minus b into bracket a squared plus ab plus b squared. Okay, so our function looks like this, right? Our expression looks like this. So we are going to have, since our expression looks like this already, it's going to be x minus 1. Following this, that will be limit as x approaches 1 of this numerator will turn to this now. That will be x minus 1, open bracket, x squared, the first term squared plus the first term times second term, which is x times 1, x, plus the second term squared, that is 1 squared, that is 1, right? Then over denominator is x minus 1. Okay, so you see, this takes care of this again. You see that now? So the limit as x approaches 1 of x squared plus x plus 1. So this is the limit we'll now take. So this becomes 1 squared plus 1, 1 squared plus 1 plus 1. Okay, that's 3. So the answer is 3. Okay? Now let's go to number 12. Number 12 says the limit as x approaches minus 2 of x cubed plus 3x squared minus 4x minus 12. Now this one, it just looks long. It might not be hard at all. I promise you, it might not be hard. So what you just do is, in my opinion, this whole thing you are seeing here is going to be a factor of this. Or, okay, let's factorize this guy. If we factorize this guy, we'll have 3 and plus x plus 3 and x plus 2, right? Yes. Or no, we can solve by polynomial. You know the remainder theorem. If you don't know remainder theorem, I'll link a video in the description. Using the remainder theorem, by remainder theorem, we are going to find theorem. We are going to find a particular factor of that guy. The remainder theorem says that if I divide that guy, if I substitute the factor, an actual factor into that guy, there should be no remainder. Exactly. So for the numerator, that's what I mean now. If I substitute, let's use 1 now. Let's put x as 1. 1 cubed will give me 1 plus 3 times 1, 3 minus 4 minus 12. So 4 minus 4 is minus 12. So 1 is not a factor. Should we go further? Okay, let's go further. Let's try 2. Put x as 2. 2, if it doesn't go, we'll just factorize this exactly. So 2 raised to the power 3, that's 8. 8 plus 3 raised to the power 2 raised to the power 2, 4 times 3, 12. Yes, to cancel out, plus minus 4 times 2, 8, minus 12, yes. So 2 is a factor. So you can already see. So since 2 is a factor, no, since 2 is one of the roots, is that clear? 2 is not a factor. What is a factor? We bring this guy in, so it becomes x minus 2 equals 0. Is that clear? So that x, we say that x minus 2 is a factor, but 2 is a root. That's what I was supposed to say. 2 is a root. Okay? So if that is the case, we use this guy to divide this thing. That was long. We use this guy to divide this guy and get the next guy. Get the, maybe another factor that this one will have. You understand? Well, let's see. If you multiply this guy by this guy, let's just do it. Let me just follow the due process. So that will be polynomial division. that'll be x minus 2. If you don't know how to do it, I'll link a video in the description, or just reach out to me on WhatsApp. I'm going to send you the video. So x in this guy is going to be x squared. This times this will give me, this will multiply all this. Take x in this one, this will give you x squared. Multiply this guy, don't go further, just come and multiply directly to give you x cubed. This times this will give you minus 2x squared, isn't it? And you now subtract. This minus this is 0. Then 3x squared minus this will give you 5x squared. Then you drop the rest, minus 4x minus 12. Then you go again, x in 5x squared is going to be 5 plus, right? Plus 5x. This time this will give you 5x squared minus, yes, plus 5 times 2 is going to be minus 10x. Then you subtract again. Yes. Then minus 4 minus this, that's minus 4 plus 10, that's plus 6. That's plus 6x. Then you drop minus 12. You see, it already looks like it. You see that? So some questions are just straightforward. You can already test. If you use this to divide this, you just get x minus 2. That's what we're supposed to do. Not this long thing. But anyways, x in this guy is going to be plus, oh no. No. So x in this guy is going to be 3 now. Oh, sorry, that's 2x. X in 6x is going to be 6. So plus 6. So that's 6x minus 12, 0. Is that clear? So this guy is the second factor. So by the time we factorize, it's going to give us the limit as x approaches minus 2 of the numerator is going to be x minus 2 times x squared plus 5x plus 6 over the denominator x squared plus 5x plus 6, which will already take care of this. Does that make sense? Alright, so we have limit as x approaches 2 of x minus 2, so that, x approaches minus 2, yeah? Minus 2. So now I have limit as x approaches minus 2 of minus 2 minus 2. So the limit will become what? Minus 4. And that is the answer for number 12. Okay, so what do? We go to the next one, number 13, which is the limit as x approaches minus 4 of x plus 4 over x cubed plus 64. Okay, so this guy. So we now have, if we substitute directly, it will give us minus 64, so it will give us an indeterminate function. Look at it. Minus 4 plus 4 over minus 4 cubed will give us minus 64 plus 64. That's 0 over 0, which is indeterminate. So we cannot substitute directly. So what do we do here? Okay, look at this. Okay, this will be the positive. So you should, now let me reduce this. This will become x, the limit as x approaches minus 4 of x plus 4 over, watch this, x raised to power 3 plus 4 raised to power 3. Okay, so recall that a raised to power 3 plus b raised to power 3 will be equal to a plus b into bracket a that thing to you need to know it exactly. By the time you work with it all the time, you will remember it. Positive will be positive here. Then a squared minus ab plus b squared. Yes. So if this is it, then we have limit as x approaches minus 4 of x plus 4 over, we said that when we have first term cube plus second term cube, or cube of 2, whatever, we're going to have the first term x plus the second term open bracket, the first term squared, x squared, minus first term times second term, x times 4, that's 4x, plus second term squared, which is 16. Okay, so this takes care of this. So we have limit as x approaches minus 4. You see, it's simple, yeah? Then when we get to rationalization, I'm seeing some strange questions in rationalization, but it's all simple. You have to just follow the mathematics step by step. Of 1 over x squared minus 4x plus 16. Then you substitute, you have 1 over minus 4 squared is 16, minus 4 times minus 4 is still 16, plus 16, 16 plus 16 plus 16. That's 32, that's 48. 1 over 48. No negative, 1 over 48, okay. So then the next, okay, so that's number 13. So let's see other questions. Or let's just move to, okay, I still have 3 more questions here. Let's just go to, okay, I think I like these questions. Let's try these ones. They have negative powers, so okay, here's what you'll do. Let me copy some questions here, then you solve and put the answer in the comment section. So we have number 14 says the limit as x approaches minus 2. So you will solve this one. I think it's quite simple. X cubed plus 3x squared plus 2x all over x squared plus minus x minus 6. Okay. What I would advise you to do first is factorize the top. Just factor x out and see what you have. So by the time you do that, put your answer in the comment section below. Let's solve this one. The limit as x approaches 0 of 6x minus 1, 6x power minus 1 plus 5x what do we do here? 5x, let's write the question first. 30x raised by minus 1 plus 2x. Let's do this. The limit as x approaches 0 of 6 over x, that's the meaning of 6x. If I have 1 over a, the same as a raised by minus 1. So that's what I just did. So all over plus 5x all over 30 over x2. I hope it's 30, not 3. Yes. Let me be sure first. 30, yes. Plus 2x. So multiply by x, multiply by x. Let's try that. Because if you multiply by x, this will take care of this, this will take care of this. Then we'll multiply this and we'll still multiply this. Is that okay? You know they're in brackets. Okay? They are bracketed terms. So we have limit as x approaches 0 of 6 plus 5x squared over 30 plus 2x squared. So what do you do from here again? So you can substitute now, so that it becomes 6 plus 5 into bracket 0 over 30 plus 0 squared is 0. Exactly. Okay. So this will be 0, this will be 0. Then we have 6 over 30, here 1, here 5. So our answer is going to be 1 over 5. Okay. All right. Let's go for another one. This one says the limit as x approaches 2 of 1 over 2 minus x minus 12x. Okay, an answer is even given to this one. So our answer, according to them, should be 1 over 2. Okay. So that means it should be simple because the answer is simple. X minus x cubed Now what do you do first? This is 1 over this, right? Yes. Okay, the first thing to do is, let's express this one in terms of what we did a while ago. So that we'll have limits. No, let's join the fractions. Is that clear? So we'll have the limit. These are our answer 1 over 2 according to them. So x minus 2 limit as x approaches 2 of, how do we take the LCM, right? So that becomes 2 minus x, and this one can be simplified into 2 raised to the power 3 minus x raised to the power 3. Okay? So by the time we solve it, this in this will remain this, right? This in this will remain this. So it will become times 1 will become 2 raised to the power 3 2 raised to the power 3 minus x raised to the power 3. No, let's simplify that first. Let's simplify it first. If we want to simplify it, to become this will become limit as x approaches 2 of 1 over 2 minus x minus 12x minus 12 over 2 raised to the power 3 minus x raised to the power 3. Okay, so remember that a raised to the power 3 minus b raised to the power 3 is equal to a minus b, a squared plus b squared plus a squared plus ab plus b squared. Yeah, either way is the same. So that we have limit as x approaches 2 of 1 over 2 minus x minus 12x minus 12 all over. This will become 2 first term minus second term, 2 minus x. Okay, then first term squared plus first term squared, that is 2 squared, that's 4, plus ab, that is 2 times x, plus b squared, that is x squared. Okay, so if you have this, we now have limit as x approaches 2 of, so we can now, okay, let's now solve, let's now join the bases now, the fractions. So we have 2 minus x is common, and 4 plus 2x plus x squared. Okay, that's the LCD. So that you say this in this LCD will remain this, right? So that becomes 4 plus 2x plus x squared minus this in this will be this, right? 12x plus minus 12, because it's the same, right? The LCD is the same as the LCD up there. So we have the limit as x approaches to of, I hope I've not made any mistake. This, yes. Okay. Okay, so we have 4 plus 2x plus x squared minus 12x plus 12 over 2 minus x, 4 plus 2x plus x squared. So what do you do from here? You will correct like terms. Let me quickly do that. This one is 10x, this one is 16. Okay, now we can factorize. Let's see. So the limit as x approaches 2 of this plus this 16 plus this minus this, that will be minus 10x plus x squared over 2 minus x over 4 plus 2x plus x squared. Okay, if we try to factorize this, it will give us if we rearrange it, excuse me, this should give us if we factorize this, we have minus plus 8 x minus 8 and x minus 2. But here, let's see. Okay, so x minus 8 and let's see 8 minus x and 2 minus x because of this. So this times is 16 minus this times is minus 2x minus 8x plus x squared. Oh. So what we will use is 8 minus x and 2 minus x to give us the numerator. So we have limit as x approaches 2 of 8 minus x and 2 minus x all over 2 minus x 4 plus 2x plus x squared. So this takes care of this, and then we have limit as x approaches 2 of 8 minus x over 4 plus 2x plus x squared. So we can now substitute so that we have 8 minus 2 over 4 plus 2 times 2 plus 4. So 4 plus 4 plus 4, that's 12, 6 over 12. Okay, so this is 1 over 2. So limit as x approaches 1 over 2, approaches 2 of our function is 1 over 2. All right, so what's the next one? Okay, we've not written any other question. This is right, and this is this. Okay, yes, our answer is 1 over 2. Yes. So you see, the concept of limit is simple. You just have to be careful when you solve questions. All right, let's go to reduction of power. Reduction of power. So I wrote only 5 questions under this. Is it 5? Yes, 6 questions. We might not solve everything. What you will do is, if you need more questions, you reach out to me so that I can send them to you. Yes. So let's work on some questions. Reduction of power, right? Reduction of power. Okay, so in this case, let me quickly give you a few tips. Let me first solve for you because we are learning how to evaluate. Then I'll now give you 2 tricks or 3 tricks that I remember. So we have limit as x approaches infinity of 5x cubed minus 6x squared plus 1. That's number 1. And number 2, Yeah, we stopped at number 16, yeah. So 16, 17, 18. Okay, so the limit as x approaches infinity again of, don't mind my infinity, or infinity, either way, of 3x raised to the power 7 minus plus 1 over 2 x raised to the power 6 minus x squared plus x. Okay, now it says negative infinity as x approaches negative infinity. So if that's the case, then number 3, let's write all the questions first. Limit as x approaches 8 infinity of x squared minus 2x raised to the power 3 plus x squared minus 5 over 2x raised to the power 5 minus 4x. Now, questions like this are the simplest. Exactly. I already know the answer from, without even solving it yet. I already know the answer. Exactly. So I'm going to show you how to do that. So we have limit also as x approaches infinity of 3x raised to the power 4 plus 2x minus 1 all over x raised to the power 4 minus x plus 2. And number 5, limit as x approaches infinity of x raised to the power 5 plus 2x raised to the power 4 minus 2x. You see these ones? I'll just use trig for maybe two of them. I'll solve one and use trig for the rest. So you see how to apply the trig. And number 6, limit as x, is this under rationalization? No. Okay, let me just write them. So you will try this, please. As x cubed over x squared minus 5. Then number 7, limit as x approaches infinity of root 9x squared plus 7 over 2x minus 8. If this one doesn't waste our time, I will solve it here. But if it does, you will solve it and put the answer in the comment section. Okay, so all right, let's solve using reduction of power method and rationalization. So we are going to solve all of these questions using reduction and all of those using rationalization. So and I would have to resolve this again because my mic stopped. So I'll start from number 1 again. Reduction of power. Number 1 says take the limit as x approaches infinity of 5x to the third minus 6x to the second plus 1. So what you want to do here, like I said, if you plugged in infinity, you get an indeterminate form. You are going to end up with 5 into bracket infinity to the third minus 6 into bracket infinity squared plus 1. This gives you infinity plus 1 is still infinity, then minus infinity. That gives you indeterminate. Okay? Which means it has no answer. So what you want to do first is to reduce the powers. Now, how do you reduce powers? We use the guy that has the highest power here. We use it to reduce power across board, across the entire expression. So which is this, in this case, this. So the limit as x tends to infinity of our function becomes x to the third. We factor it out, okay? And that's how we reduce power. We factor this guy out so that we have 5 left here, 5 alone rather here, minus, what can we use to multiply this guy that will give us this guy? That's going to be 6 over x plus 1 over x cubed, so that by the time you open the bracket, you're going to get 1. So recall that a constant over infinity is going to give you 0. Okay? A constant over infinity will give you 0. So because for example, if I use 2 as my constant and I divide by big numbers like 1000, for example, if I divide 2 by 1000, I'm going to get 0.002. If I divide by 10,000, this is going to decrease further to 0.0002. By 100,000, 0.000002. So you see that the value of the numbers keep reducing. So that's why when you divide a constant by infinity, you're going to get 0. So here we have that these guys will eventually tend to 0 by the time we plug in this guy. So the limit as x tends to infinity of our expression becomes 5x cubed. Now we can plug in infinity so that we have limit as x tends to infinity of this guy becomes 5 into brackets infinity cubed. Infinity cubed is infinity times 5 is still what? Infinity. So that's going to be our answer. Then number 2 says that limit, we should take the limit, evaluate the limit as x tends to minus infinity, negative infinity, of 3x to the 7th plus 1 over 2x to the 6th minus x squared plus x. Now, we're going to use the same approach, factor out the highest power. So we have x, the limit as x approaches negative infinity of our expression becomes x to the 7th into bracket. 3 will be left here, plus, now, this guy is going to be 1 over 2x that you multiply with this guy to give you this guy, okay? Minus 1 over x to the 5th plus 1 over x to the 6th. So, in like manner, this guy is going to give us 0 by the time we plug in infinity or even negative infinity. We plug in negative infinity is going to give us 0. Plug in negative infinity, we get 0. So at the end of the day, the limit as x approaches negative infinity of our expression becomes 3 into bracket x raised to power 7. So by the time we plug in negative infinity here, we have limit as x approaches negative infinity of 3 into bracket negative infinity raised to power 7. Now negative infinity raised to power an odd number is going to be negative infinity. Okay, if it were an even number, it's going to be positive infinity. So in this case, we have 3 times negative infinity is negative infinity. Yeah, and I said that this term, negative infinity, for example, I said limit as x approaches negative infinity, is different from this term, limit as x approaches infinity raised to the power minus. This thing means that we are approaching infinity from the left. Okay, so on your Cartesian, it's going to be we're approaching positive infinity from the left. Okay, but if you add positive here, it means we're approaching negative infinity from the far end. So from infinity, we are going to infinity. Does that make sense? Okay, I mean, it doesn't even make sense. You can't approach infinity from positive. Anyways, that's just the meaning. Okay? So, number 3. Now with number 3, this sort of problems comes with a particular trick that I'm going to show you. So we said that limit, number 3 says the limit as x approaches infinity of x raised to the power 6 minus 2x raised to the power 3 plus x squared minus 5 all over 2x raised to the power 5 minus 4x. Okay? So if you want to solve this, before I show you the trick, here is the reduction power method. Reduction of power method. So the limit as x approaches infinity of this value becomes, of these are guys, becomes, we are going to divide by, now you're going to, the denominator is going to be your focus now. The denominator is x raised to the power 5. So it has the highest power, which is x raised to the power 5, has its highest power to be x raised to the power 5, okay? So that x raised to the power 5 is what you will now use to divide everybody on top and under. Does that make sense? So you have x raised to the power 6 over x to the 5th minus 2x raised to the power 3 over x to the 5th plus x raised to the power 2 over x to the 5th minus 5 over x raised to the power 5 all over 2x raised to the power 5 over x to the 5th minus 4x over x to the 5th. By the time you solve, you cut, this one is going to remain 1. So the limit as x approaches infinity of our guys become x here, only x will be left here, minus this guy is going to give us 2 over x squared plus x plus 1 over x to the 3rd minus 5 over x to the 5th. Then we have, this takes care of this, leaving 2 behind, minus 4 over x to the 4th. Now, at the end of the day, by the time you work these, like I already said, constant over infinity is going to give you 0. So, by plugging in infinity into these equations, these already become 0. So, we are left with x. So, the limit as x approaches infinity of our expression becomes x over 2. Okay, so x is now infinity when we plug in the value x, infinity rather, over 2. So infinity divided by a constant is going to give you what? Infinity. So here is the brainer. The trick is this. Whenever you have an expression like this, the numerator has a higher value, a higher term than the, I hope I'm not disturbing you. Okay. The numerator has a higher value, a higher power than the denominator. So that is going to be called, we will call it top heavy. Then if the numerator has a lower power, has its highest power lower than the one in the denominator, that is, the denominator has its highest power greater than the highest power above it, that's going to be bottom heavy. Okay, now if they now add equal powers, as we have in number 4, raised to the power 4 raised to the power 4, then that's going to be equal powers. Okay, equal powers. So bottom heavy is going to be like in question 5. So I'm going to give you the trick. The trick is this. For top heavy, when you are asked to take the limit of a top heavy expression as x tends to infinity, now positive infinity, your answer is going to be infinity all the time. When you are asked to take the limit as x tends to infinity for a bottom heavy expression, your answer is going to be 0 all the time. So this one, for both negative infinity and infinity, is going to be 0 all the time. But for this guy, if you are now asked to take the limit as x tends to negative infinity, then it will now depend on the power of that your numerator, because it is top heavy, so it will determine whether it's going to be positive infinity or negative infinity. But for your equal powers, your answer is always going to be the coefficient of the powers that will be left behind, of the highest powers. So in this case, you can already guess that the answer is going to be 3 over 1. Does that make sense? 3 over 1. That's going to be what? 3. In this case, if this were 6, for example, so that both of them are of equal powers, your answer is going to be 1 over 4. Does that make sense? So that's just the trick. Albeit, I'm still going to show you that the reduction of power method works. So we're going to do number 4 using that same method. So we have limits as x approaches infinity of 3x raised to the power 4 plus 2x, 2x minus 1 all over x raised to the power 4 minus x plus 2. So in this case, what you want to do is this. You divide through by the highest power of the denominator, not the numerator. So the limit as x approaches infinity of our expression becomes 3x raised to the power 4 over x raised to the power 4 plus 2x over x raised to the power 4 minus 1 over x raised to the power 4. over x raised to the power 4 over x raised to the power 4 minus x over x raised to the power 4 plus 2 over x raised to the power 4. So since you already understand what I've been doing so far, it is preconceived that this is 0, this is 0, this is 0, this is 0 at the plugging in of our infinity, yeah? So that makes sense. Then this is 1, this is 1. So we are going to be left with the limit as x approaches infinity of our expression is going to be what? 3. 3 over 1 is 3. Okay. So the next one is this, number 5. So this is bottom heavy. You can already tell what the answer will be. Alright, then this one, number 6. You solve and put the answer in the comment section below. Okay. Now what you will do is make this guy over 1, then merge the fraction. Make it a single fraction so that you will know whether it is top heavy or bottom heavy or equal basis. I doubt it will be equal, but just do it and drop the answer in the comment section. So then for number 7, number 7 says the limit as x approaches infinity of the square root of 9x squared plus 7 over 2x minus 8. Now, at the first sight of this question, what I was thinking was we'll use rationalization. But you cannot use rationalization on this term because I don't know why yet. But it's not rationalization I will use. So this is what you want to do. You first look at it well because it's not hard. Do you understand now? So what will you do? You see this guy? So this is what you will do. It's very simple, exactly. So do you know what you will do now? What you will do is you will factor out, let's factor out this guy, this x squared. If we do that, the limit as x approaches infinity of this expression becomes the square root of x squared into bracket 9 plus 7 over x squared. So let's be careful in order not to make mistake. 2x over 2x minus 8. You know why I did that? The reason why I did it is so that I'll separate so that this guy can stand alone, exactly. So that we have the limit as x approaches infinity of this guy becomes the square root of x squared dot the square root of 9. They are multiplying. So you have to be good at mathematical manipulations, okay? Over 2x minus 8. So from here now, what you now do is, what's the square root of this? Is x, right? So the limit as x approaches infinity of this thing becomes x root 9 plus 7 over x squared, okay? All over 2x minus 8. Okay, so what do we do from here? Okay, from here, what we can do is, we can now divide through by x. So this becomes this entire thing here over x, then this over x, then this over x. So this takes care of this takes care of this. So we have the limit as x approaches infinity of this guy becomes square root of 9 plus 7 over x squared all over 2 minus 8 over x. Okay. So from here, if you plug in infinity, this will give you 0, this will give you 0. Okay. So the limit as x approaches infinity of our expression now becomes root 9 over 3 over 2. So root 9 is what? 3 over 2. So this becomes our answer. So you see it's not hard. Okay? It's not hard at all. At all, at all. Alright, let's proceed to rationalization. The method of rationalization. Let me... Alright, so let's solve by rationalization all of these questions. Number 1 says that the limit as x approaches 0 of root 4 square root of 4 plus 3x. So you see, the first problem with mathematics as with limits with this guy, as with other aspects of math, is copying the wrong question. So you must attempt, I said attempt, you must never write the wrong question. Minus 2, so be careful as you write, that's what I mean, over 5x. So what you want to do here is you want to rationalize. And how do you rationalize? Here is what rationalization is. If I have root A plus root B over 1 and I wanted to rationalize this thing, I'll multiply up and down, numerator and denominator, by the conjugate of this guy. And what's the conjugate of this guy? That's going to be square root of A minus square root of B over square root of A minus square root of B. So if this be the case, then, so this is just conjugate. That's what I mean here. So what we're going to do to rationalize is we'll multiply by the conjugate of the numerator, which will be square root of 4 plus 3x plus 2. Okay, the conjugate is the term that contains the same expression but a different sign, an opposite sign. So in this case, plus all over the square root of 4 plus 3x plus 2. Alright, so we can now multiply. Now don't let it confuse you at all. If you multiply, if you remember the difference of two squares, you have a squared minus b squared is the same as a plus b multiplied by a minus b. I've showed you this before. So if you multiply this and this, if you multiply conjugates, you are going to get difference of two squares. That's what I mean. If you multiply conjugates, you are going to get what? Difference of two squares. So this guy times this guy is going to cancel the square root so that the limit as x approaches 0 of our expression becomes 4 plus 3x. Then this guy, you are going to square it, minus 4 all over. I hope that is clear. Let me explain. Now, and this is the only time I will explain that. This times this will give you the square root times the square root. That's just like saying 4 plus root 4 plus 3x squared. It's going to square will cancel square root. So I left with this. Then this times 2 will give you positive 2 times this, or positive 2 roots this, and negative 2 times this will give you negative 2 roots, the same thing. So that annuls each other, and then you have 0 there. Then you now have this times this will be a square of this, which will give us negative 4. I hope that is clear. So the next thing you want to do is you will now use the denominator to open this, okay? So, but since it's looking weird, what I'll just do is 5x into bracket the square root of 4 plus 3x plus 2. Plus 2, sorry. Okay? So if this is the case, then let's solve the numerator. Plus 2 takes care of plus 4 takes care of minus 4. So we have the limit as x approaches 0 over 10 becomes 3x over 5x multiplied by, yes. So seeing this, x can also take care of x, right? Let's just cancel it from here. No, let's bring it here. Square root of 4 plus 3x plus 2, close bracket. So this takes care of this, and we have the limit as x approaches 0 of 3 over 5 into bracket the square root of 4 plus 3x plus 2. Okay? So we can now plug 0 into the equation. By the time we plug 0 in, we have the limit as x approaches 0 of our expression becomes 3 over 5 into bracket root 4 plus 3 times 0. What is 3 times 0? 0, right? Then plus 2. So we have 3 over 5 into bracket. Square root of 4 is 2 plus 2, that's 4. 4 plus 4 multiplied by 5, 20. So we have the limit as x approaches 0 of our expression becomes 3 over 20. Okay? Yeah. All right. So you see, it's short and simple. No, it's not short. It's long and simple. It's long and simple. Okay, so number two is short, so it should be short too. Yeah, I mean it's small, so it shouldn't give us problem. The limit as x approaches 0 of root x minus x all over root x. So what do you want to do from here? Rationalize the same way. Very simple. Now, I took the numerator to rationalize here, to rationalize here. I took the conjugate of the numerator here because it is the complex term. Okay? Here, because this root is in the denominator, we'll use it. Is that clear? We'll use it. I'll give you, if there's a special case where we have to choose between up and down, we should choose the numerator. Is that clear? All right, the denominator, the guy down. So multiply up and down by root 2, root x over root x. So that this becomes limit as x approaches 0. This will now be, let's put this guy outside, of this minus x all over, this will give us x here. Let's open the brackets then. So by the time we open the brackets, we'll have this by this will be x minus x root x all over x. So we have the limit as x approaches 0. So we can cut through, right? Divide, split the fraction. Well, how do you say? You split the fraction, so we have this guy here 1, this guy here 1, this guy here. So we have limit as x approaches 0, 1 minus root x. So when x becomes 0, so square root of 0 is 0, and the limit of our expression becomes 1. All right, so you see it's simple and short. No, short and simple. Now the next one, I promise you will not be simple and short. But it's not hard either. So number 3 says the limit as x approaches 3. Whenever you are given a limit, whenever you are told to take a limit of a number, limit of an expression where the x will tend to a whole number, I promise you it's usually easy. It's usually easy. So we have 1 minus, because you can test, exactly. Not like you cannot test with the others, but this one is definite. Over 9 minus x squared. So what do you want to do here? The first thing you want to do is multiply by the conjugate of the numerator. So you see we are choosing the numerator now because it's the one that needs rationalization. So times 1 plus root 4 minus x over 1 plus root 4 minus x. So it becomes limit as x approaches 3 of the numerator will give us 1 minus 4 minus x. Does that make sense? Because when you multiply, I told you it's going to give you difference of 2 squares. 1 squared minus this guy. This guy squared, which is going to take care of the square root. So over 9 minus x squared into brackets 1 plus root 4 minus x. And you also see something that I'm not quick to resolve or simplify my denominator. I'm not quick to do that because something might come up, So the limit as x approaches 3 of our function, because of our expression, becomes minus this minus 1 minus this is going to give us minus 3. Minus 3, right? So we have minus 3 minus x over we already have difference of 2 squares here. So that's going to be 3 minus x multiply by 3 plus x, all multiply by 1 plus square root of 4 minus x. So from here, you can factor out negative so that you have limit as x approaches 3 of minus 1 into bracket 3 plus x over 3 minus x, 3 plus x, you cancel here. So over 1 plus the square root of 4 minus x. Okay. So we can now substitute or plug in our 3. So the limit as x approaches 3 of this expression becomes minus 1 over 3 minus 3, 0. Oh no, we cannot do that yet. We cannot, right? Why can't we? We can't because the denominator will become 0, right? So here's what we can do. Here's what we can do. If we try to use this guy this 0, this 0, what do we do? 3 minus x, 3 minus 3 plus x. Does that mean? Don't worry. Okay, so one of my unique mathematicians called my attention or drew my attention to this. By the time you open this, you multiply this, you are going to bracket this term. Exactly. So that by the time you bracket, when you open the bracket, you're gonna have a numerator 1 minus 4 plus x. Does that make sense? So that you have minus 3 at the top or at the top, and that's the numerator. You're gonna have 1 minus this is minus 3 plus x ahead. So you have 3 plus x here still. So by the time you rearrange this, you're going to have x minus 3. Okay. If you don't want to rearrange it, if you leave, okay, if you leave minus outside, okay, we have this plus x. Let's leave minus outside. We're going to get 3 minus x. Does this make sense? So if we want to do it this way, so we just leave minus out here. So we have 3 minus x over 3 minus x, 3 plus x over 1 plus root 4 minus x. If you don't understand what I did here, I'll drop his WhatsApp number so that you can call him. So you do this, and then you have the limit as x approaches 3 of minus 1 over 3 plus Jesus Christ. We solve 3 into that. By the time we solve 3 into that, it gives us 9 into bracket 1 plus the square root of 4 minus 3. So 4 minus 3 is 1. 1 plus 1 is 2. 2 times 9 is 18. So the limit as x approaches 3 of our expression we call minus 1 over 18. 4 minus 1, 4 minus 3, 1, square root of 1, 1. 1 plus 1 is 2 times 3, 18, okay? So this is going to be the answer. So then let's solve the last the number 4, yeah? So if I don't finish it, you are going to solve the rest and put the answer in the comment section. I don't like it. Gospel. Gospel has left. Where's Gospel? I'll need him to help me check this one. So that like if I make mistake, you understand? Like to be helping me to just to be following me. You can do it too, yeah? Tutu. Follow me, Mama, so that you will know if I'm, you know when you face the camera, there's just this, I don't know, just be following me. Sometimes I want to write 3, I'll write 2. Yeah, it happens. Okay, so here, if you want to rationalize this, you fix this over 1, then you multiply by the conjugate of this term, which will be square root of x plus 5 plus root x all over square root of x plus 5 plus root x. So by the time you multiply this by this by this by this, your limit as x tends to infinity of this expression becomes this multiplied by this. We just remove the cap here, the square root, then plus 5 minus this by this, it's going to give us just x, right? Okay, because it's going to be minus root x all squared. So square cancels square root. Okay, so then the denominator, we still have this. That will be square root of x plus 5, then plus root x. This guy, the denominator, numerator. And yeah, you know that this is like conjugate, so it becomes difference of 2 squares. So if you square this guy, take square of it, square this guy, take square of it. Alright. So this minus this is going to leave 5 only there. So we have limit as x approaches approaches infinity of the expression becomes 5 over square root of x plus 5 plus root x. From here, we are going to, what can we do? Let's attempt to divide through by square root of x. If we divide through by square root of x, we have the limit as x approaches infinity of our expression becomes 5 over square root of x. That is, everybody is being divided by square root of x now. All over here plus 5 over square root of x, then plus root x over square root of x. Okay, from here, you see that this is going to give us 1, right? Then this one will become the limit as x approaches infinity of our expression becomes 5 over root x all over this will, square root, yeah, of everything of x plus 5 over x, then plus 1. Okay? So at here, this expression becomes root x over x plus 5 over x, yeah? This takes care of this. So what we have overall here is going to be the limit as x approaches infinity of 5 over root x all over square root of, here we got 1 plus 5 over x plus 1. 1 plus 5 over x all plus 1. Okay, so from here, we can let's try to substitute infinity into this. If we do that, is it infinity? Yes, it's infinity. Okay, if we substitute infinity here, we get 0 here. If we put infinity here, square root of infinity is infinity, yeah? So 5 over infinity is 0. So the entire thing is 0. Okay, so the limit as x approaches infinity of 5 over square root of infinity over square root of 1 plus 5 over infinity plus 1. I've not made any mistake, have I? Because I was thinking, like you followed it from all this, right? Okay. So what does this become? This will give us 0. So the limit of our function as x approaches infinity becomes 0. Okay. So that is that for this guy. Now this number 5 is very simple. So because of that, I will solve it. You're expecting me to say what? Eh? Can they? Dark, yeah? Yeah, of course, because of the light. And they will see it in the name of Jesus. It's already even. So now we have the limit as x approaches 9 of root x minus 3. I'm trying to make my handwriting bolder, more legible. So we are going to rationalize the numerator by root x plus 3 over root x plus 3. Okay? So these multiplied by this will give us the limit as x approaches 9 of our function becomes x minus 9 all over x minus 9 and root x plus 3. So this takes care of this. So the limit as x approaches 9 of our function becomes 1 over square root of 9. When we substitute 9 to it, plus 3. This becomes 1 over 6. Yeah? Right? Thank you. So then the last one, you see, I solved it. The limit as x approaches infinity again of root x minus 4x all over 12x plus 5. Okay? So if you want to do this, you rationalize the same way. You multiply by square root of x plus 4x all over the square root of x plus 4x. So by the time you solve the numerator, you have limit as x approaches infinity of x minus 16 squared, 16x squared. We square this guy here, and we square this guy, negative. Then we have, then this one we still have 12x plus 5, close bracket. Don't be too quick to evaluate the denominator. Okay? Even though now we have to do something. So let's open the brackets. Let's open the brackets for the numerator. First, let's factor out. Now let's open the bracket first of the denominator. So our denominator alone becomes, this multiplied by this gives us 12x root x plus this times this gives us 48x x squared plus this times this gives us 5 root x plus 20x. So from here, this and this, okay, they are not like terms because this one has x outside. Okay? So what we can do is the denominator, our function becomes the limit as x approaches infinity of x minus 16x squared over 12x root x plus 48x squared plus 5 root x plus 20x. We have to do some manipulations here. So we have this over this. So let's use reduction of power now, since we can use that. So we divide through by the highest power of the denominator, which is x squared. So we'll have the limit as x approaches infinity of x over x squared minus 16x squared over x squared all over 12x root x over x squared plus 48x squared over x squared plus 5 root x over x squared plus 20x over x squared. This takes care of this, this takes care of this. Here is going to be left with 1 under, then here it remains 1 under. Okay, so let's write what we have. We'll have the limit as x approaches infinity of our function becomes 1 over x minus 16, okay, over 12 root x over x plus 48 plus 5 root x over x squared plus 20 over x. Do you remember that 1 over root, I'm coming, look at this, 1 over root 2, you know it's the same as root 2 over 2, right? Right? Okay, so you agree with me that this thing is the same as 1 over root x, so 12 over root x. You agree, eh? So if this one is like this, of raised to power 1, then this one raised to power 2. This will be x raised to power 1 over 2 over x squared, right? I'm trying to solve it. So x raised to power 1 over 2 minus 2. That becomes x raised to power minus 1 over 2, minus 1 over 1 over 2, which is x raised to power minus 3 over 2. If we write this, this can be written as the square root 1 over the square root of x cubed. Look at the manipulation I did here. Look at the manipulation I did. So this, so it becomes limit as x approaches infinity of 1 over x minus 16 over, we said this one will become 12 over root x plus 48 plus, we said this one will become 5, what we got was 1 over root x raised to power 3. So you know that this is correct, right? Yes. So 5 over root x raised to power 3. And it's not like the, yeah, it's the same either way. So then plus 20 over x. So from here, what else can we do? Nothing. We tried our best. We can go home. We should impute infinity here. If we do that, this becomes 0, this becomes 0, this becomes 0. We didn't even need to do any manipulation. So our answer becomes what? Exactly. Right? Wait. Yes. Okay. So our answer becomes limit as x approaches infinity of minus 16 over 48. Here 1, here 3. So our answer becomes negative 1 over 3. All right. So that will be the end of this video. In the next video, I'm going to show you the L'Hopital's rule and Squeeze Theorem. Okay. Then I will now show you in another video how to use all the methods of differentiation, and I'm going to link the video where I did parametric equations. Someone sent me a question on parametric equations, so I solved it and I'll short the video. So I'll link the video in the description. God bless you as you share the video and subscribe to the channel.